This is a lesson on weather. Some of the things may sound familiar because we watched little videos and I've gone over in the lab and things like that. But we really need to understand these processes before we can understand extreme weather like lightning and thunder and hurricanes and tornadoes. So humidity. Humidity is defined by the amount of water vapor that's in the air. So for instance, Florida is seen to be very humid because we have a lot of water vapor due to our location. We're surrounded by water on 3 sides. Relative humidity is the amount of water vapor in the air compared to what is needed to reach saturation. Saturation basically means that the air would be 100% water. So your relative humidity, it's like the percentage that it would take to get you to complete 100%. So on a hot summer day, when it's warmer, the air will, you have a lot of evaporation occurring. So your relative humidity is going to be less because the air is like constantly being evaporated. In a cold autumn day, your relative humidity might be a little bit higher because you don't have as much evaporation occurring. Fronts. So we're going to review fronts. You have cold fronts and warm fronts. So fronts form between different air masses. So that's when you have like one side you have like a cold and you have a warm on the other. Warm could be here, cold could be here. This is just an example. There's 2 things that's going to depend on: temperature and the moisture and humidity. So that will dictate what kind of front you have. The warmer your temperature, the more moisture is in the air. The colder the temperature, the less moisture in the air. So first you have cold fronts. It pushes up any warm air like a wedge. It will rain if the warm air has a lot of moisture, but that will be short-lived. So anytime a front, they hit each other for the first time, you're usually going to have some rain. But the thing about cold fronts is right afterwards, you're going to have that high pressure system, which we'll go into in a second, and that's going to produce clear skies and cooler weather. So once this hits and goes through, then you're going to have that clear, calm weather. The symbol is a line like this with triangles that points in the direction of movement. And if you take a look at this picture here, you'll see how it hits it like a wedge. So when the cold air front comes in, it's going to be a wedge. It's going to push the warm air up. That's why the warm air going up is going to cause a little bit of rain at first, but then afterwards you have that clear skies. Okay, so your warm fronts. So now you have your warm fronts. Your warm fronts warm air is less dense than cold, so that's going to form kind of on top of the cold air because it's going to have in this fashion. Warm air rises over the cold air, and as it does that, it's going to condense and produce clouds. When that happens, the warm fronts will bring drizzle rain, but after that you'll have warm, clear weather. This weekend is a perfect example of what happened. On Friday we had drizzle and clouds, and then Saturday we had really hot, clear weather because a warm front came in. And the reason why, again, is in the beginning, you're going to have clouds that form. Your symbol is going to be a line with semicircles on it, and it's pointing in the direction of the movement of the air. And what I mean by that is, that means because the circles are on this side, that means the warm air is moving this way. And you can see the air is here. High pressure systems. So we're going to get into pressure systems. High pressure systems, remember your high is cold. So high pressure systems are cooler, denser air. Your air is going to sink. As your air sinks, it gets warmer and it will start to absorb moisture. What will happen because of that, your water will evaporate, your humidity will decrease, and clouds start to disappear because you basically have more air to absorb all that moisture, and you're going to get clear skies and calm air breezes. So when you think a high pressure system, think that there's like a cold, dense air just moved through, so everything's kind of sinking and absorbing all that moisture. So because of that, you have pretty skies. So high pressure systems are accompanied with sunny days. Low pressure systems are the opposite. So it's warm, less dense air, so that means your air is going to rise. As your air rises, it's going to cool and form clouds and rain because of all the moisture that was in. So when your air is down here, it's constantly just absorbing a lot of that. The rising air in a low pressure system causes stormy weather because it's bringing up all that moisture. And we'll talk more next week about what happens in your clouds to make the stormy weather. So you have your high pressure sinks, low pressure rises, beautiful clear days, cloudy, rainy days. What does it look like on a map? So your high pressure systems are going to be written with a blue H, because high pressure systems are called by cool temperatures, and the arrows are going to be pointing in clockwise direction. So it's going to be going around like this. Your low pressure systems are written in a red L, red, because low pressure systems are caused by warm weather, and they're going to be arrows are going to be pointing in a counterclockwise. So it's going to be going the opposite direction like this. Okay, again, a review. I've noticed there are some students that are still kind of confused with what precipitation is, and that may be surprising to some, but I just wanted to go in and review it and actually give you guys definitions so you have it somewhere. So precipitation is any form of water that falls to the Earth's surface. You have snow, sleet, rain, or hail. I do have freezing rain in here, which is similar to hail, but I wanted to show a picture of that too. So your snow is going to be like single ice crystals. Sleet is going to start as rain and then falls through cold air, which solidifies it. Rain is just water droplets that fall when it gets too much. Hail is layer lumps of ice that fall. And then to measure all this, you have something called a rain gauge, and it measures the water that is collected. We'll make one of those sometime. We'll see if there's any rain coming up. Clouds. So there's three types of clouds. You have cirrus clouds. Your cirrus clouds are wispy. They form when you have strong winds. So the strong winds were kind of pushing it, making it like a thin layer. Then you have cumulus clouds. Cumulus means heap or pile. The taller they get, so this wouldn't be so bad, but the taller they get, that's when you're going to get thunderstorms. I'm going to show you what that looks like in a minute. And then you have stratus. Stratus is going to be that thin layer of clouds. They spread out and they're flat and they cover the sky. The lower and the darker they are, they'll block out the sun, and you'll get that drizzle and that rain, which is on those dark, cloudy days. So here is I'll go back to that. So here is a cumulus clouds. This is actually from Maui. Someone took this very, very recently. I actually had it on my, it was a Nat Geographic Travel, I believe. And you can actually see how they're stacked, right? The stack. And as they stack, this is in Maui, this is in Hawaii, and you actually see the thunderstorms occurring. And again, next week we'll talk more about what causes that. But for now, you just have to know what the clouds are called and what they produce. Okay, so that's it. Just kind of a review. There's probably the only new real thing that we went into was cloud cover. But we have to make sure that we know the difference between high and low pressure and temperature. And I know a lot of you guys are still struggling with that. We'll be spending the next couple of days getting more comfortable. Okay, so that's it. Alrighty.